Hello everyone, I am Faranjum from Sri Venkateshwara College of Engineering, Bangalore. The topic for the presentation is probability distribution from the course Mathematical Foundations for Computing, Probability and Statistics. The contents of the presentation are probability distribution, terminologies in probability distribution, random variables and its types, cumulative distribution function, discrete probability distribution, list of formulae, an example problem, and the real-time applications of probability distribution. First, what is probability distribution? A probability distribution is a mathematical function that gives the probabilities of occurrence of different possible outcomes for an experiment. It is a mathematical description of a random phenomena in terms of its sample space and the probabilities of events, that is, the subsets of the sample space. For example, if x is used to denote the outcome of a coin tossed, then the probability distribution of x would take the value zero point 0.5 for x equals to heads and zero point 0.5 for x equals to tails, assuming that the coin is fair. From the following figure, we can see the probability distribution is of two types, discrete and continuous. The terminologies in probability distribution are experiment, random experiment, event, and probability. First, experiment. An operation which can produce some well defined outcomes is called as an experiment. Random experiment. An experiment whose outcomes cannot be predicted in advance is called random experiment. Event. Performing a random experiment and outcome is called as an event, which is denoted by E. Probability. The probability of event E is given by P of E, which is equal to the number of favorable outcomes divided by the total number of possible outcomes. Random variables. If a real variable x is associated with the outcome of a random experiment, then x is called random variable or variate. Random variables are usually denoted by x, y, and z, and it is noted that different random variables may be associated with the sample space S. The types of random variables are discrete random variable and continuous random variable. Discrete random variable. A discrete random variable is one which may take on only a countable number of distinct values such as 0, 1, 2, 3, and so on. For example, bouncing the ball and observing the number of times it bounces. Continuous random variable. If a random variable takes non-countable infinite number of values, then it is called non-discrete or continuous random variable. For example, weight of newspaper bundle. Cumulative distribution function. In the special case of a real valued random variable, the probability distribution can equivalently be represented by a cumulative distribution function instead of a probability measure. The cumulative distribution function of a random variable x with regard to a probability distribution p is defined as f of x equal to probability of random variable x less than or equal to x. The cumulative distribution function of any real valued random variable has the following properties. F of x is non-decreasing, f of x is right continuous, f of x lies between 0 and 1, the limit x tends to minus infinity, f of x is equal to 0, and the limit x tends to infinity, f of x equal to 1. The probability of x lying between a and b is equal to f of b minus f of a. Discrete probability distribution. If for each value of xi of discrete random variable x be assigned a real number p of xi such that if p of xi is greater than or equal to 0, then summation of p of xi is equal to 1. Then the function probability of x is called probability function. Therefore, the set of values xi p of xi is called a discrete probability function. The list of formulae which are used in the probability distribution are mean, which is denoted by mu, equal to summation fi xi divided by summation fi, or summation x into p of x. Variance, which is denoted by v, or sigma square, is equal to summation fi of x minus mu the whole square divided by summation fi, which is equal to summation of x minus mu the whole square into p of xi. Standard deviation, which is denoted by sigma, is equal to square root of v. Here is an example problem. A random variable x has following probability distribution function for various values of x. Here we need to find the value of k, mean, variance, standard deviation, probability of x less than 6, probability of x greater than or equal to 6, and probability of x lying between 3 and 6. Also, find the probability distribution table and the distribution function of x. Now, let us assume that p of x is greater than or equal to 0. Therefore, summation of p of x is equal to 1. So, we add all the values of p of x and equate to 0 to find the value of k, and we find the value of k as 0.1. Therefore, the distribution table is as follows. The mean, or which is denoted by mu, is equal to the summation of x into p of x. We get the mean 3.66. Variance, which is denoted by V or sigma square, is equal to summation of x minus mu the whole square into P of xi. We get the variance V is equal to 3.40439. Standard deviation, which is denoted by sigma, is equal to square root of V. We get the standard deviation sigma equal to 1.845. Now, let us find the probability of x less than 6, which is equal to p of 0 plus p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5, which is equal to 0.81. For the probability of x greater than or equal to 6, we get p of 6 plus p of 7, which is equal to 0.19. For the probability of x between 3 and 6, which is equal to p of 4 plus p of 5 plus p of 6, we get 0.33. The distribution function of x is f of x equal to p of random variable x less than or equal to x, which is equal to the summation from I is equal to 1 to x p of xi is called distribution function of x or cumulative function of x. Distribution function of x table is as follows. The real life applications of probability distribution are weather forecasting, stock market, politics for voting to find out the probability of the winning party, flipping a coin or dice, insurance, lottery tickets, playing cards. Thank you for watching the video.